Hey friends, today we're talking about solving logarithmic equations. Okay, we are on page number 11 in our Module 6 packet. There are two things that I need for you to know about solving logarithmic equations. Okay, the first thing is that we cannot take the logarithm, I'm just going to say we cannot take the log of 0. Okay, we cannot take the log of the number 0. So, in other words, the number that's inside my parentheses, okay, if all of this simplifies to give me a 0 and it says log base 5 of 0, we know that that is not possible, okay? The second thing is we cannot take the log of a negative number. So, if I plug in my x value or values and I simplify what is inside here, if the number that's inside these parentheses is a negative number, that will not be possible. So, thank you. All right, what we're going to do, this is pretty similar to when we were solving our exponential equations, okay? Except I might have a few steps to do beforehand, okay? The first thing that we will want to do is condense each logarithm. Now, condensing is making everything small. Okay, you want to put everything that's on one side of the equation into one single logarithm. Okay, and then we're going to use the one-to-one property. If both sides of my logarithm are equal to each other, if I have log base b, or for example, log base 2 of m and log base 2 of n, then we know that m and n are equal to each other. So, I know this sounds funny, but we can basically say we're going to drop the logs. Yes, I know that sounds gross, but we can drop the logs and then solve for our variables, okay? And then, this step is very important. We did not have to check any of our solutions for our exponential functions, okay? But if I work out my equation, excuse me, and I get some numbers that when I plug them back in, it causes either one of these two situations to happen, then we have what we call an extraneous solution, okay? So here we go. Right here on both sides of the equation, I have single logarithms, and both of them have the same base. Now, because the logarithms with the base are the same, that means that the numbers or the expressions inside those logarithms are equal to each other. So I'm going to drop the logarithms and I'm going to solve for x. I'm going to subtract 5x on both sides. Okay, so this ends up giving me x is equal to 9. Okay. So I want to plug this in and I want to check it. If I take 9 and I plug it in, 9 times 5 is 45, and 45 plus 9 we know is going to give us a positive number. That's fine. And then here, 9 times 6 is a positive number. As long as I plug this in and check that I'm going to get a positive, our solution is fine. Okay? Now over here, we have two logarithms on the same side of the equation. So I'm going to condense these into one. When I am adding my logarithms together, the property is that I multiply these two expressions together. So this is going to give me log of, and this is like a distribution, 4y plus 20. And then that's going to be equal to log of 72. I've got two logs with the same base equal to each other, so that means the number inside is going to be equal as well. So I've got 4y plus 20 equals 72. I'm going to subtract 20 on both sides, so I get 4y equals 52. And when I divide both sides by 4, okay, now, if you know anything about a deck of cards, you know there are 52 cards and there are 4 suits. In each suit, there are 13 cards. Okay, that's how I remember that multiplication fact. Okay? All right, now if I go plug this 13 in, the only one I have to check is this first one, because when I plug it in, y plus 5, that's the only one that has a variable. This is just log of 4, and this is log of 72. There's nothing to substitute that into, okay? So 13 plus 5, that is a positive number. So that solution is fine. Now I do want to point out that you plug your solutions back into the original equation, the ones before you ever condense them, okay? All right, next, right here, I'm going to take this 3 that is being multiplied by log base 7 of 4, and based on your properties that you learned before Thanksgiving break and in Algebra 2, this 3 belongs as an exponent to the 4. So I have log base 7 of 4 to the 3rd power equals 4a minus 8. Okay, I've got, that's a 7 right there. Logs with the base are the same, so this ends up giving me, I have 64 because 4 cubed is 64. Okay, and then that's going to be set equal to 4a minus 8. I'm going to add 8 to both sides. This gives me 72 equals 4a. And when I divide both sides by 4 here, okay, when I divide both sides by 4, 72 divided by 4 is 18. So my a value is 18, okay? If I go plug in 18 to my original equation, 4 times 18 is going to be a pretty big number. We can check this. 4 times 18 minus 8. Okay, I'm checking this right here. I do get a positive number, okay? So that solution is good to go. All right. Once again, looking at my properties, the left-hand side does not change. There is nothing to manipulate here. But on the right-hand side, this 2 is being multiplied by log base 3 of 6. And I also have subtraction here with another log base 3. So I'm going to kill 2 birds with 1 stone. Okay, I'm going to condense this and raise this to this exponent at the same time. Right here in the numerator, I'm going to have a 6 squared. This goes in the numerator because it's positive, a positive leading coefficient. And then this 4 is going to go in the denominator because it follows a minus sign. So this is log base 3, not log of 2. I'm sorry about that. Right here I have 2p minus 5. And then over here on this side, this is going to end up being 36 divided by 4, which is 9. And I'm going to solve for p. I'm going to start by adding 5 to both sides. Okay, that gives me 2p equals 14. And here, p equals 7. Now, if I'm checking my solution, I'm plugging it in right here. 2 times 7 is 14, and 14 minus 5 is 9. There are no other variables to plug that into, so I'm good to go. Okay? Next, right here, I have log base 4 of 4, and one of them is m squared, and the other is 18 minus 7m. Okay? These bases were the same, so I was able to drop those logarithms. Okay? So now I see that I'm working with a quadratic. When I am working with a quadratic, I want one side set equal to 0. So I am going to move this negative 7m to the right-hand side. And I'm also going to move the the left-hand side. Okay? I want to factor this. The two numbers that multiply to give me negative 18 that add to give me 7 are positive 9 and negative 2. 9 times negative 2 is negative 18, and 9 minus 2 is positive 7. So there are two situations here. There's a situation where m plus 9 equals 0, and m minus 2 equals 0. So I have two potential solutions. I have negative 9 and I have positive 2. Now, right here I got a negative number as a solution. Up here we mentioned that we cannot take the log of a negative number. That doesn't mean that my solution cannot be negative. It means that when I substitute this back in, that what I'm taking the logarithm of cannot be negative. So, when I go and I check this, I've got negative 9 squared. That gives me a positive 81. So far this negative 9 is fine. And here I've got 18 minus 7 times negative 9, which gives me also a positive 81. This negative solution is fine. Now I want to check the 2. 2 squared is 4, and 18 minus 7 times 2 is 4 also. So that solution works as well. Okay? All right. On this one, I want to condense my logarithms. Okay? So right here, if I'm adding 2 logarithms with the same base together, I'm going to multiply these 2 pieces together. So I end up with the log of 2k squared, and that equals the log of k squared plus 16. I've got the logs on both sides. Okay, so I'm going to get rid of those. And now I'm solving 2k equals k squared plus 16. Okay, so I'm going to solve for k. This leaves me with k squared equals 16. When I come through and I take the square root of both sides, I get 2 solutions. I get k is positive 4, and I get that k is negative 4. Okay? So, I need to check both solutions. If I plug in a 4 into k, 4 squared is 16. That's fine. And here, 4 squared is 16 also. This one is fine. K equals 4 works. Now, I want to remind you, when I am substituting in a negative number, please do not forget that you are responsible for putting that negative number into parentheses. Okay? So that one's fine. And then I come right here. This also, the negative 4 squared is going to give me 16, and I'll add that 16. So both of these solutions work. Now this was type 1. This is where I have 2 logarithms set equal to each other. I have the logs on either side of my equation. The second type of equation that I'm going to look at is where my equations, I have a logarithm equal to a number. Okay? We want to condense and isolate the logarithm. Okay? If I've got a number, just like I do right here, I want to get that number on a side all by itself, and I want the logs on a side all by itself. Okay? I'm going to write the equation in exponential form, and then I'm going to solve and check for extraneous solutions. Okay? Just a reminder, when I don't have to condense here. I have a log equal to a number, and I write it in exponential form. This is where I draw my little loop-de-loop to help me. So here I have 2 to the 6th power equals x minus 4. Well, 2 to the 6th power is 64. 64 equals x minus 4. And when I add 4 to both sides, I get that x is equal to 68. Checking my solution, if I do 68 minus 4, I do in fact get a positive number. Okay? Right here for this one, I've got an additional number that's not part of this logarithm on the left side of my equation. So the first thing I want to do is isolate the logarithm. That means I'm going to start by adding 7. So I have log base 3 of 4x plus 8 is equal to, oops, that would be 4. I almost put 10. Okay. Now I'm going to rewrite this in exponential form. I have 3 to the 4th power equals 4x plus 8. 3 to the 4th power is 81, but just showing you how I get that in the calculator. Okay, 3 to the 4th power is 81. So 81 equals 4x plus 8. Subtract 8 on both sides. 81 take away 8 is 73. And if I divide both sides by 4, okay, then I get that x is equal to 73 divided by 4. Now I want to check this, okay? I want to make sure that when I plug 73 over 4 into this expression, that I end up with a positive number. 73 over 4, okay, and then plus 8. I do in fact get a positive number inside this logarithm. I don't care about the rest of everything. I'm only checking this logarithm, okay? All right. Right here I have 2 logarithms on the same side of the equation, so I need to condense that. If I have addition, that means I'm going to multiply these 2 together. So that means I'm going to multiply 2x into my set of parentheses. So that's 2x squared minus 10x, and that equals 2. Okay? Now there is an understood but unwritten base of 10 here, so I can still convert this into exponential form. I end up with 10 squared is equal to 2x squared minus 10x. That's 100. Okay. Now I'm going to take that 100 and I'm going to move it over here. So I have one side set equal to 0. So that becomes negative 100. Okay. Now I see a GCF. So I'm going to divide out a 2 from every single factor. Uh-oh. That gives me 50 back here, not 10. Okay? And then I want to factor my quadratic. This gives me, let's see, the 2 numbers that multiply to give me negative, that should be a negative 50, sorry. Negative 50 that add to give me negative 5. That would be negative 10 and positive 5. So anything that has a variable is what I will solve for my solutions. That gives me positive 10 and negative 5. Okay? So I am taking each one of my solutions and I'm plugging it back into the original. Okay? So we know 2 times 10 is 20. That one's good so far. And 10 minus 5 is 5. That still gives me positive numbers. Okay? So 10 is a solution. But if I plug in negative 5, 2 times negative 5 is negative 10. We cannot take the log of a negative 10. So right here, I am going to automatically cancel this out. This would be considered an extraneous solution. Okay, it does not work, so I don't even write it down as a solution. Okay, so x equals 10. Next, I've got subtraction, so that means I'm going to have a fraction. This 2 that's sitting out front as the coefficient becomes the exponent of the x. Okay? So this is the log of x squared minus 4, divided by 4, creating a fraction there, and that equals 2. Remember, there is an unwritten but understood 10 as the base. I'm going to convert this into exponential form. So this is 10 squared equals x squared over 4. This becomes 100. And I want to get rid of the division. So right here I have x squared equals 400. And when I take the square root of 400, that gives me positive 20 and negative 20. Okay, you got to have a plus or minus when you take the square root. If I am looking at plugging in these solutions into my original equation, this is the only thing I need to check. X equals 20, that's fine, because I'm taking the log of a positive number. But we cannot plug in negative 20 because we cannot take the log of a negative number. So x equals 20 is my only solution. Once again, I am going to condense my logarithms right here. So that means with addition, I'm going to multiply. So on the left side of my equation, I have log base 6 of x squared plus 9x, and that equals 2. I'm going to convert this into exponential form. So I have 6 squared equals x squared plus 9x. This is 36, and since I'm working with a quadratic, I want to move it to the left side of my equation. So I have 0 equals x squared plus 9x minus 36. I am going to factor. That gives me x plus 12 and x minus 3. 12 times negative 3 is negative 36, and 12 minus 3 is 9. So my two potential solutions are negative 12 and positive 3. When I go and I substitute negative 12 back into either one of these, okay, negative 12 plus 9 is a negative 3. That's a no-no. But plugging in that negative 12 here is also a no-no. Okay, so negative 12 is extraneous. 3 plus 9 is 12, and I am allowed to take the log of 3. So 3 is my only solution. The last one on page 11, I am once again condensing. I am adding two of the logarithms together, so I'm going to multiply. So this gives me log of x squared minus 3x, and this equals 1. There is an understood but unwritten base of 10. If I put this in exponential form, this is 10 to the first power equals x squared minus 3x. 10 to the first power is just 10. So when I move this over, I have x squared minus 3x minus 10. Okay? And this factors into x minus 5 times x plus 2. So I get two potential solutions of positive 5 and negative 2. 5 minus 3 is 2, and I can plug that in right here as well. So 5 is good. And when I take this negative 2 and I try and check it, negative 2 minus 3, that's negative 5. Okay, and you also can't plug that in there. So I'm going to call negative 2 an extraneous solution. Okay? All right, flipping over to page number 12, okay, I'm going to solve these two logarithmic equations. Now this one just looks a little bit more involved because you have 3 pieces on the left-hand side. And yes, we want to condense all of those into one logarithm. They all have log base 3. Okay, so I'm going to go ahead with the left side. I do see subtraction, so I know that creates a fraction. Okay, both the log base 3's that lead this left side are positive, so that means the factors of y minus 2 and y plus 15 will be in the numerator, and the factor of y minus 1 will be in the denominator. Okay, so right here, what I'm going to do, okay, I'm going to go ahead and I am going to multiply out right here. Actually, I'll do that in a minute. Let me simplify this a little bit. I am going to take this and I'm going to go ahead and put this in exponential form. This is 3 squared equals y minus 2 times y plus 15 all over y minus 1. Now my job is to solve for y, okay? I don't know what it's going to be yet, so let's get going, okay? We know that this 3 squared will turn into a 9, okay? One thing I do not like is the fact that this right here has division. So I'm going to multiply both sides by the entire y minus 1 factor, and that eliminates the fraction. This becomes 9 times y minus 1 equals y minus 2 times y plus 15. I am going to distribute on the left side. This is 9y minus 9. And then I'm going to multiply all of this out on the right side. I end up with y squared. We have 15y minus 2y, so that's plus 13y. And then negative 2 times 15 is negative 30. Okay. Because this is a quadratic, I'm going to take this stuff and move it over. So I'm subtracting 9y and adding 9. So I have 0 equals y squared plus 4y minus 21. Okay, so my job is to now factor this simplified quadratic. Okay, so let's see, the factors of negative 21 that add to give me 4 are positive 7 and negative 3. So my two solutions here, y'all, are going to be negative 7 and positive 3. But I have to check each solution. If I plug in negative 7, automatically, right off the bat, negative 7 minus 2 more, that's a negative number. So I'm going to say that that is extraneous. Here, if I plug in 3, 3 minus 2 is 1. That's fine. 3 plus 15 is 18. That is fine. And 3 minus 1 is 2. So y equals 3 is my only solution to this equation. Okay, now I'm going to do this one. Okay, on the left side, I have 2 natural logs on the same side. Okay, I'm adding them together, so that means that I want to multiply those together. Okay, now I notice on the other side I also have a natural log. Okay, so this is one of those ones like the first type of equation that I tried to solve today, where we've got the logs on both sides. So if the logs are the same, we can pretty much just drop those and work with what is inside. So I'm going to multiply this side out. This gives me w squared. I have negative 9w minus 2w, so that's negative 11w, and I have plus 18. And this leaves me with negative 2w plus 10. Once again, I'm taking these pieces and I'm going to move them to the left side so that I'm working with my true quadratic. I'm going to add 2w and I'm going to subtract 10. So I have w squared plus 9w, I'm sorry, not plus, that would be minus 9w, and then plus 8 equals 0. The two factors that multiply to give me positive 8 that add to give me negative 9 are negative 8 and negative 1. So that means my two potential solutions are positive 8 and positive 1. I want to check these, okay? Right here, if I plug in 8, 8 minus 2 is 6. That is fine. If I plug in 8 here, 8 minus 9, that's negative 1. So this is not going to work. That is extraneous. So let's move to the next. 1 minus 2, that's negative 1. So y'all, this one doesn't work either. We cannot take the natural log of negative 1. So if both of my solutions end up being extraneous, my answer will be that there is no solution. Okay? All right. I am going to skip down here to the bottom of page 12, okay? And I'm just going to work through these together with you, okay? Continuing on. Just notice these have natural logs, whereas I've been working with logs, okay? Natural log on one side, natural log on the other side, so we can just set 4x minus 27 equal to 15 minus 2x. I'm going to add 2x to both sides, and I'm going to add 27 to both sides. Oops, I didn't mean to cancel that out. That should give me a 6x, and then right here, this should give me, let's see, 15 and 21, that's 42. So x equals 7. 7 times 4 is 28, and 28 minus 27 is 1. Okay, and then 15 minus 2 times 7, 2 times 7 is 14. We can do 15 minus 14, so this solution is fine. Okay, this 2 becomes the exponent of this k. So I have the natural log of k squared is equal to the natural log of 2k plus 15. The natural logs on either side, I can pretty much just drop those right there. And I am working with k squared equals 2k plus 15. I'm working with a quadratic, so I want one side set equal to 0. Okay? This factors into k minus 5 and k plus 3. So my two potential solutions are positive 5 and negative 3. I can plug in positive 5 right here, okay? And 5 times 2 is 10. 10 plus 15, that's still positive, okay? So 5 is good. But y'all, when I plug in this negative 3 into that original, you cannot take the natural log of negative 3. So this is extraneous. Okay? All right. Down at the bottom, right here, okay, there is an understood E written there for this base. So if I have a log or a natural log equal to a number, this is where we are going to convert into exponential form. This will be e squared equals 8x. And to solve for x, I'm going to divide both sides by 8. Now, in the calculator, right above the division key, in blue letters, you will see a blue E. So, to get E, I'm going to do second division, and then I'm going to raise it to the second power. I'm going to go ahead and hit enter, and then I'm going to divide by 8. Okay? So right here, I get x is approximately 0.924. If I plug a positive number in here, then I will be able to take that logarithm. Okay? All right. Here we go. I am solving for x. I want to get rid of this exponential right here because my x is in the exponent. So that means I need to actually convert this into logarithmic form. So all I need to do right here to get my x value is type in ln and 57 and hit enter. And I get 4.043. All right, now, because this was an exponential equation to begin with, I do not need to worry about checking my solution. Okay? All right, last 4 problems. Okay? Right here, I want to move this right here to the other side. I'm trying to isolate my variable. So I have e to the y plus 3 power is now equal to 30. Now, I'm trying to get up here in this exponent, and I cannot do that unless I get rid of this exponential. So I'm going to turn this into logarithmic form, and when I take log base e, that is the natural log, That's going to be the natural log of 30 equals y plus 3. Now, remember in the calculator will open up parentheses. I need to immediately close those, and then I am going to subtract the 3 in the end. So right here I have the natural log of 30 minus 3. So my y value is going to be approximately, I'm going to do ln of 30, close those parentheses, and minus 3. Okay? So I get a decimal of 0.412. Okay? All right, for this next one, I have a variable up in the exponent that I'm trying to solve for. Okay, I need to start by dividing both sides by 5. Okay, 95 divided by 5 is 19. So I have e to the 4n power equals 19. I need to get to the variable, so I need to undo the exponential. So I am going to take log base e, so that's the natural log of 19. It will open, so you make sure you close those parentheses, okay, equals 4n. And then we will divide both sides by 4. So right here, since this is in fraction format, just to add an extra layer of protection with this to make sure that we do not divide 19 specifically by 4, I'm going to do the natural log of 19 in the numerator, and then I'm going to do 4 in the denominator, and I get approximately 0.736. Okay? All right. Next, once again, I am trying to solve for c. So I need to isolate everything else that is around this e to the c minus 9 power. The first thing I'm going to do is subtract 3 on both sides. This gives me 2e to the c minus 9 power equals 84. I'm going to divide both sides by 2. So I have e to the c minus 9 power equals 42. Now that I have this right here in exponential form, I need to get up here to this variable, so I'm going to convert it to logarithmic form. Log base e is the natural log, so I'm going to take the natural log of 42. That's going to open, so you close those parentheses. And I have c minus 9. So c equals the natural log of 42. Open and close those parentheses. And then you want the c by itself, so you add 9 to both sides. Okay? So c is going to be approximately, I'm going to do the natural log of 42, close those parentheses, plus 9, and I get approximately 12.738. Okay, now this one looks totally different. Right here, we cannot break 5 down anymore, and right here, I cannot write 10 with anything that has a base that is 5. So what I'm going to do, I'm just going to go with simplifying one thing at a time, and I think that maybe because I know my common logarithm, I'm going to try and get rid of this base of 10. So what I'm going to do, I'm going to take the log base 10 of both sides. When we take, remember, when we take log base 10 of 10, okay, this basically cancels itself out and it's equal to 1. So this right here, if it becomes 1, it's just going to leave me with what my exponent is, okay, which is just 4x minus 7. Okay, now I have log of 5 to the 2x minus 7 power. Okay, now the first thing that I'm going to do, okay, I'm going to see if I can break some things apart, okay, based on my exponent rules. Okay, I'm going to leave this 4x minus 7 alone for right now. What is my exponent rule that I'm doing when I multiply two things together that have the same base? We're adding those exponents. So what I'm going to do is I'm going to break those exponents apart. And so I'm actually kind of separating my logarithms. Okay. All right, now let's see what we can do. The first thing that I'm going to do is take this 2x and move it out as the coefficient, and same thing with the negative 7. Okay, so this becomes 4x minus 7 equals 2x times the log of 5 minus 7 times the log of 5. Now, what I notice on this side of my equation is that both of these terms have the same factor. So I'm going to treat log of 5 as if it is a GCF. So I'm going to take 4x minus 7, and I'm going to take this log of 5, and I'm going to remove it, and that leaves me with this 2x minus 7 right here in parentheses. Okay? Now, log of 5, if I just get a numeric value, I'm going to round this. I'm going to change this and say 4x minus 7 equals, let's see, 0.699. And this is 2x minus 7. Okay? Now that this is a numeric value, I'm going to distribute this back out so that I can then start to work towards solving x. Notice now all of my logarithms are gone. Okay? So I have 4x minus 7 is equal to 0.699 times 2 is 1.398x, and 0.699 times negative 7 is negative 4.893. Okay? Now, just like any two-step equation, I am going to move my variables to one side and my numbers to the other. So 4 minus 1.398, that gives me 2.602x. And if I add 7 to negative 4.893, that gives me 2.107. And y'all, all I have to do to solve for x here is divide both sides by 2.602. Now this was a hot mess, but it is possible to solve for x. So I'm doing 2.107 divided by 2.602 and hit enter. Here I have x is approximately 0.81 or 810. Okay? That is solving logarithmic equations as well as some exponentials in there with e.